Welcome, guys. Welcome back. I say welcome back because we have been going through our 3-a-day multiple choice marathon. Today, we're at episode 9, which means that we've come a far way already. We're almost at the end of week 2, and I hope that this has been helpful for you so far. Guys, let me know in the comments how beneficial this is for you. All right, and don't forget to share with somebody else. Do. All right, so we are getting ourselves through our first multiple choice past paper, and this will be done by the time we're done with week 4. So today we are going to be doing questions 25, 26, and 27 of past paper 2019. That's what we started with. So I'm open already. Take out on a pen, on a book, on everything, and we're ready to roll. We're ready to rumble. Don't forget that what is 2 nights from now? Yes, Saturday night at 7 p.m. We have Saturday Night Live. We'll be doing past paper questions, but of course, paper 2 every week is a different topic. Anyway, we're here for our 3 multiple choice questions today, so I'm not gonna hold you much longer. All right. So question 25 says, the sum of 2 positive numbers, P and Q, is 32. Their sum is 32, and their difference is 12. And the question is asked, what is the smaller number? Now, you can play around with numbers. You can go ahead and test numbers and say, which number I can add them and I get 32, but if I subtract them, I get 12, etc. And some persons will be able to just tell you off the top of their heads, right? Just by thinking about the numbers for a few minutes or a few seconds. But just in case you're not able to do that, I can show you how to. All right, so it says that the numbers are P and Q. First of all, we're going to say P plus Q is going to be 32. But if I subtract them from them one another, we get 12. So me writing this right here, we are obviously basically saying that P is the bigger number. All right, so eventually we want to ensure that we know the value of Q. Anyway, let's go. So if you look at these, you can see that these are 2 simultaneous equations, 2 equations that we're going to be solving simultaneously at the same time. All right, so there are 2 ways we can do this. And you would have heard of the elimination method and the substitution method. Now with elimination, you would be deciding right now what variable you're going to be getting rid of. By the way, the fact that we want to find Q, you may not want to get rid of Q, but you can. All right, so either way, it's the same thing. So even though you can eliminate P now and it will allow you to find Q, let's say you didn't notice that and then you just went ahead and just simply chose any one of them to eliminate. All right, I'm going to choose Q. And I like to encourage students to choose the variable that has same coefficient. For example, Q has a coefficient of 1, same coefficient, different signs, because I find that students find it easier to add integers than to subtract them. All right, so here we go. P plus P, that gives us 2P. Q plus a negative Q, that's going to give us 0, equals 32 plus 12 is going to give us 44. We divide both sides by 2. We now end up with P equals 22. P equals 22. All right, so obviously that's our bigger number. And now we can go ahead and substitute this 22 into any of the equations, and we will get our answer for Q. So we can use equation 1. So now we're substituting P equals 22 or 22 for P in equation 1. You could have tagged these if you wanted, equation 1, equation 2. All right, and so we now have P plus Q equals 32, which means this is 22 plus Q equals 32. Subtracting 22 from both sides, we have Q to be equal to 10. Which of these are a smaller, is our smaller number? We have 10. All right, so that would have been our answer. The second way how we could have done this, so we have the equations P plus Q equals 32 and P minus Q giving you 12. We could have used the substitution method, which means that we take one of these equations and we make one of the variables the subject of the formula. So let's say we take equation 1 and we're making P the subject of the formula. So we're going to get rid of Q from this side. So we now have P is equal to 32 minus Q. This 32 minus Q, which is equal to P, we're going to take it and substitute it into our second equation. All right, and that's going to be, so P is 32 minus Q again, because we're putting it into this equation, equals 12. And so now we have 32 minus 2Q equals 12. We can go ahead and subtract 32 from this side, 32 from this side. And now we will have negative 2Q equals negative 20. And so Q again would have been equal to 10. Do we have to do anything else to find P? No, because they want a smaller number. All right, so that's it. We will now move to our second question, which will not take us that much time, definitely. All right, question number 26 says 3x squared times 2x cubed is equal to what? And so we're gonna go straight to the numbers first. 3 times 2 gives us 6, so we know D is not the correct answer. We also know that x squared times x cubed, when we are multiplying variables, so once we're multiplying same base being this big variable here, we can go ahead and add the powers. 2 plus 3 would have given us 5. So that is 6x to the 5th power. If you did want to do this, you can. X squared times x cubed. You would have gotten x to the 5th power. All right, so 6x to the 5th power is our answer. And we move to question number 27. Question number 27, which says, 2 matrices A and B are conformable for multiplication if, so how can you tell if 2 matrices can be multiplied? Of course, I could just tell you, but I also want you to remember this for future use. So I'm going to also show you. Let's say we have these 2 matrices. Let's say A is 3, 1, 2, 4. We're trying to multiply that by 2, 3, 1, 4, 6, 1.
We know that to multiply 2 matrices, we can go ahead and multiply the rows in the first matrix by the columns in the second matrix.
All right, and so you would have said 3 times 2 plus 1 times 4. All right, and then you would have also taken that 3 and multiplied it by that 3 and 1 and multiplied it by 3 and 6, etc. You take the 3 and 1 again and multiply by 1 and 1, etc.
So each time you're multiplying, you have 2 elements in the first matrix being multiplied by 2 elements in the second matrix. You're also going to take the elements in the second row and multiply it by each of the columns in the second matrix.
Fine, which means these 2 matrices can be multiplied. Now, what do we notice about these 2 matrices? The first matrix has 2 rows and 2 columns. It's a 2 by 2 matrix. And the next matrix has 2 rows and 3 columns. All right, we're just making that observation. And they can be multiplied. Now, I'm going to show you a situation where the matrices cannot be multiplied, and we're going to see why. Let's look at 3, 1, 2, 4 times 4, 2, 5, 4, 3, 3. All right. Let's try to multiply. So we would have gone 3 times 4, and then we add that to 1 times 5. 1 times 5. And then we don't have anything to multiply the 3 by. This is when you know that the matrices cannot be multiplied by each other. Now let's make an observation. What's the order of this matrix? 2 by 2. That's 2 rows by 2 columns. And the order for our second matrix here would have been 3 rows by 2 columns. The reason the first set of matrices could have been multiplied is that notice this number here is the same. The number of columns in our first matrix, columns, was equal to the number of rows in our second matrix. And so our answer would have been B. In the second example that we did, we noticed that the number of columns in the first matrix was not equal to the number of rows, and that's why they could not have been multiplied. So if you end up getting a question like this again, then you know how or how not they can be multiplied. All right, so that's our final question for today. All right, stay tuned. That means subscribe. If you're new here, you can go ahead and tell me that you're new here. If this was helpful, guys, go ahead and say it in the comments that this was helpful for you. All right, it's goodbye from DG Makes Math Easy. This is Donisha Gordon. See you tomorrow.